My name is Fabio. I work for ThoughtWorks, and we're gonna have this conversation slash interview with Nat Pryce today. So thanks a lot, Nat, for joining us. Nat is very well known for his passion in the testing design space, and then he's got a book called Growing Object-Oriented Software Guided by Tests, which some people refer to as GOOS. But I'll give Nat some time to introduce himself, and then I'll explain a bit of how this thing will work. So thanks a lot, Nat, and can you just give a bit of introduction?
Hello, yeah, I am a co-author of Growing Object-Oriented Software Guided by Tests along with Steve Freeman. I'm a freelance software developer in London, and I've worked with a variety of companies like e-commerce, embedded systems and consumer devices, finance industry, TV, and as an architect doing training, but mostly sort of software development and some sort of consulting and advising on software development and architecture as well.
Cool, yeah, thank you so much for joining. We've been looking forward to this interview for a bit of time, and just wanted to mention that we had 200,000 impressions on Twitter on the hashtag TDDisevolving. So if anyone wants to tweet anything, please use the hashtag TDDisevolving. And I think throughout the interview, you'll understand a bit more why we're calling this the TDDisevolving. And if you have any questions, we'll have a Q&A at the end, but please post them on the Google Hangouts Q&A section, or if you want to as well, post a question with the TDDisevolving hashtag on Twitter, and we'll try to answer the questions at the end. So this will be a 1-hour conversation. So bear with us, and please post your questions. And to start with, Nat, I wanted to ask you one thing, which is you're very well known for a few things, but the one thing that stands out when we think of you is the testing. So why you decided to focus your efforts in the community and in that area?
Oh, I don't know if maybe I'm known for testing, but I don't think that GOOS book and a lot of what I do is really about testing. I think testing is sort of part of a holistic process. I think of the GOOS book really about design and how we use the writing of automated tests to get feedback on our design, on the quality of the code and the systems we're producing, but also on the internal quality, the sort of the quality of the design that helps us work with the code and evolve it steadily throughout the life cycle or lifetime of the system.
So it's more around the design bit, not necessarily the test. And what do you think is the correlation between the design and the testing?
So I think what I find is that writing tests forces me to, well, firstly think about what I want to achieve. So writing, like following a test-driven process, if you're very strict about it, which I like to be, forces you to think about what you want the software to do, or the piece of the software that you're writing to do, or the whole system to do, when the system isn't actually written yet. So you're not bogged down in implementation details. You're not testing in terms of implementation. You can only really test in terms of the problem domain and the solution that you want to produce. So that forces you to sort of think about what you want to achieve rather than just going down a rabbit hole of implementation detail. And then as you apply testing to the system as it's growing, in order to make the tests run fast, be easy to understand, that they kind of force you to introduce a more compositional style into your code. So you break the code down into pieces that have useful what's the word, sort of abstraction in your code that allows you to put some tests around it, feel confident in the quality of the and behavior of the abstraction, and then put it to one side and not have to think about the implementation of that while you then continue to use it to build higher and higher, more and more sophisticated functionality on top of it. So you end up with these very nicely compositional systems where you can work at a very higher level, and the level that you're working at gets higher and higher and more abstract and closer to the domain as you work.
Cool. And since we're talking a bit about the evolution of TDD, it's hard not to think about BDD as well as when it came up as a concept. And how do you see those two concepts and the differences and similarities between them, TDD and BDD?
It's difficult. BDD has a fuzzy definition, and TDD itself, I guess, somewhat because of the rise of BDD, has had its definition somewhat shrunk. When I started, TDD and BDD were kind of the same thing, but then sort of BDD ended up being the name given to the space of capturing requirements in an automated form that acts as living documentation in conversation with the users. I've always considered that to be an essential part of test-driven development. And test-driven development isn't just unit testing, it's kind of the mental process of thinking about how we're going to test something, how am I going to show that it's working to myself or maybe to other people, and capture that knowledge. I think what goes under the umbrella of BDD is very valuable, and I think that I've had great success with it. I've also had terrible failures with it, and I think at the moment BDD is sort of getting confused with some of the tooling that is being used for BDD, and I don't find all of the tooling very useful, but I find the collaborative process is useful. So collaborating with people on shared, capturing shared understanding of what the system has to do is a very useful practice. Now, you don't have to use Cucumber or Fit or something like that to do it, or Concordian. You can actually build your own tools. And I actually like to go and find out what the users of my software, or people who care about what the software does that I'm building for them, how do they think about their domain and how the software will fit into it? What tools do they like to use? And can we build some tooling for the specification, by example, or BDD processes on the tooling that they like in the mental models that they have already about the system, rather than turning up with a tool that's come from an IT background that I've downloaded off the internet and say, right, now change all your thinking about your domain into this particular tool's format. So for me, BDD is a great way of helping me understand the domain that I'm working in. I'm building software for people, because often in my job I'm working in, I go into projects and it's a domain that's new to me, and so I've got to learn quite fast, and BDD and capturing knowledge in automatable form is a great way of forcing you to really understand stuff.
Cool. So you mean when someone just starts using Cucumber, that doesn't mean they're doing BDD?
Absolutely, yes. I have seen a lot of Cucumber used as a sort of awkward scripting language, rather than a way of capturing knowledge in a way that communicates well. And you can use it to capture knowledge in a way that communicates well, but if you start off with the idea, I'm going to use Cucumber, you can go down the wrong path very easily. But if you start off with the idea, how can we build a shared knowledge of what we want to achieve and capture that in a useful form, Cucumber might fit or it might not, but at least you're starting off with on the right foot.
Cool. And what are some of these, because you mentioned the BDD is not just about the tooling, and sometimes it gets confused with just the tooling, but you mentioned some things around the process and people talking to each other, and what are some of these things, if you've got someone watching who's never done it, what are some of these key areas of the BDD process or specification, by example, that you would say that they help?
So do you mean like where does BDD help, or what can we do to help BDD?
The process itself. If someone was like, oh, I've never done BDD, I'm going to do BDD now, but it's not just about the tool, it's not just using a tool. What else is it? What kind of pieces of the process would you say? Because you mentioned a few people talking to each other. Is that early on the process? Is that what roles would that be? And yeah,
I think it's really important to get the right people collaborating on these documents. No one's going to read them. The overhead of the tools that you either use or build is very high, and I have also had great success just refactoring a lot of our Java tests until they are readable by non-technical business analysts and other stakeholders. As long as they're sitting at the computer with a developer, we can talk about them and change them and work together on them. So you don't need to have documentation in a traditional form. To me, it's very much about the collaborating on these documents, having a format that we will agree on to capture knowledge in a way that communicates to everybody, and don't expect that to be static, because as you go through the project, just as you have to continue to refactor your code and adapt your design to new requirements, the way that you document your system will change. You'll learn new things. You want to represent that new knowledge in ways that will therefore require changing the documents that you've already built. And you need to make sure that the tooling you're using and building doesn't impede that process. And also just the processes that you set up organizationally. These are shared documents, and you need to have sort of a shared process where everyone sort of works on them together, rather than they're being owned by the test team and no one else can change them once they've been nailed down. So it is a somewhat radical change to the way some organizations are structured to work in this way, and that can make things a bit awkward to start with, but once it clicks in, I've had great success with it. And most of the times when I've had terrible failures with it, it has been because we've been unable to join these silos together in a way that we can properly collaborate on evolving this living documentation.
Cool. That's good. Yeah. So you mentioned a few things on the BDD scripting and some of the ways that you're using a BDD tool, but the way that the script is actually written is not really expressing the behavior. There's some of the maybe anti-patterns of the things, right? Things that people do, and it's not really supposed to be that way when someone came up with the idea. So on a similar topic, I like to heat up a bit the discussion. Last year, there was a huge debate around the fact that TDD was dead or TDD wasn't dead, and what does dead mean? And what was your opinion during the time of the debate about this whole discussion?
Yeah, I admit I only watched the first one. I didn't find it very riveting, so I didn't watch the next few. But I mean, it's a bit of an absolute. People are using TDD. It's very successful. I say if anyone or any community has any reason to say TDD is dead, maybe it's the strongly typed functional programming community. But Ruby is not really a place where I can see any alternative really that is as useful as like modern type systems in addressing some of the same issues that TDD addresses. I mean, I talk to a lot of Ruby programs. I don't use Ruby myself, but and obviously it's a self-selecting set. The people I talk to are people who like GOOS and talk about OO design and TDD. So I'm sort of like talking to people who are interested in that anyway. But the impression I get is that people in the Rails community who are applying hexagonal Rails and are trying to apply some of the ideas from GOOS and the PUDA book by Sandy Metz and some of the more old school these days OO design ideas from Smalltalk and so on. They're not trying to sort of decouple themselves and apply that architecture in order to do TDD, but they're using TDD in order to be able to decouple their code from the framework, from Rails, whatever framework they're using, in order to give them some option if the evolution of the framework moves off in a direction that they are not able to follow or comfortable with or whatever. So I think that they are using TDD to get the decoupling that they want, rather than applying unnecessary decoupling in order to do TDD. And in that case, I don't really think that TDD is dead. It's just they have different constraints, different engineering constraints than somebody who is authoring a framework that they are building their own applications on. Right? If you're building applications on a framework that you don't have as much control over, you need to then pay for different, insurance, different options, engineering options, in order to address that risk in your project.
Cool. Yeah, that's very right. Completely agree with you. There was during the debate, the TDD debate, there was a conversation around mocks and what good ways of using mocks, and that mocks were probably overused sometimes. Did you have any views on that at all?
Yeah, I mean, the example that was given, I think DHH might have given it, a mock returning a mock returning a mock. I mean, mock returning a mock, at that point you think, stop, enough. When we design mock objects, sort of the technique, I mean, it originated from Connextra, and then was picked up by people who were at the Extreme Tuesday Club meetup in London. That was a meetup of people who were trying out XP and had learned it from the patterns community. The XP people, Kent Beck, Ron Jeffries, and everyone turned up on the C2 wiki and were writing about XP, and a lot of people who were interested in patterns in London were like, oh, this is interesting, and it seems to resonate with the way we would like to write software. And we're all in these horrible bureaucratic processes where people throw software over the wall. I remember projects at the time which literally went for months without even actually being able to compile the software. So the idea that you have continuous integration, always running all the time, every single commit is fully tested, was a kick in the pants. And the fact that you had these very lightweight processes and could react quickly was really great. So there's a real excitement in sort of programming community, or certain parts of it in London, and people were trying out these things and experimenting. And Connextra was a company that was using XP across the board. And a lot of the problems they were coming into before anyone else, and they were sharing their ideas, and mock objects was one of those. And it kind of coincided with, they were people who came from a small talk background, and so the code they were writing, they wanted these objects that would send messages to each other. They had this kind of mystical view of OO, as Ralph Johnson would call it, where you think of objects as these sort of self-contained things that you send messages to, and they just do something on your behalf. So the idea that you would have to assert on their state felt wrong. So they created this technique in order to allow them to apply the test-driven development sort of feedback loops, but in a design style that was more message-driven, tell, don't ask, object-oriented, rather than munging state and looking at state. So the code that they wrote, and certainly the code that I normally write and Steve writes and other people who sort of write with mock objects in that style, is quite different from a lot of mock object code that I see. I've seen code on the JMock mailing list, a few years ago. Someone was complaining about JMock. Said, "Oh, I've got a base class with 5,000 mocks in it, and then I've got a subclass of that for each test, and that has 1,000 mocks in it, and I have to do all this setup for every test." Very different from the kind of code that we were writing, where there'd be one or two expectations in a test, and each test was very small and self-contained, and then the objects were composed together into sort of event-driven data flow pipelines and things. So it fitted a certain style of code. Now that style of code is not applicable to every part of your system or every system you write. Certainly, if I look at a web app, bits of code that are handling I/O events and dealing with a low-level HTTP protocol are quite event-driven, and so fit an OO model quite well. But the bits of code that are taking resources and transforming them into representations and streaming them across the network, that's much more functional. So I don't use mock objects there, but I certainly see a lot of mock object code where they're just mocking getters, lots and lots of getters. They're just using mocks to not create an object that's basically just a bag of stuff with no behavior. And so, yes, that code becomes really horrible to test in mock objects. But it's not really designed for that. We didn't design the mock object technique for that kind of code, and we would use something else for that. I think in the GOOS book, one of the one of the sort of not disappointments, but I think we really didn't emphasize this idea of having some objects which are stateful and communicate by message passing, mostly in tell don't ask, and then you have value objects which are immutable and transformed and then the objects that are sort of doing the coordinating, applying then these transformations in like more sort of functional style inside themselves to sort of transform the data. We sort of mentioned value objects, but we didn't really talk a lot about that distinction as much as we should have done, I think. And certainly that's sort of a distinction that I find myself introducing into legacy code bases that are, mix up all of these things in one big complicated blob.
Oh yeah, you mentioned people mocking gets and getters and setter methods, and you're right. Like I've seen that happen a lot. I don't know. I wanted to hear your opinion on one thing that I think a lot when I see code like that, which is the concept of unit testing. I think from what I heard from many people that I was pairing with and who told me this is a unit test, so we can't interact with other classes because a unit test is supposed to test just one class. So it feels to me that sometimes the need to mock everything around a particular class comes from this concept that we're doing unit testing and a unit is a class and it has to be necessarily that class or a method. And then if I'm testing, I've even seen people mock one method from the same class that they're testing because they thought the unit that they were testing was the method. So the boundaries of the test had to be that one method, and if that one method interacted with anything else around it, if it was another class method or even a method from the same class, that had to be isolated because that wasn't unit testing. So that I feel sometimes that people are a bit caught up with the concept of what a unit is. Do you have any opinions on that, like the name of unit testing and what a unit is when we're testing?
Yeah, I mean, in an OO language, classes create objects, and those objects contain other objects in them, and so I think people overdo the isolation, and then you end up with objects that are not a useful abstraction in and of themselves because you have to pass too much to them, and then they don't really have an abstraction. Their internals are sort of passed in as well as their peers, and so it is nice to be able to think, right, I'm testing a behavior of a particular class, and that class is a really useful abstraction, and inside it is quite a lot of complexity, but the API hides it. So there are sort of rules of thumb that I try and follow that we talk about a bit in the book. One of them is a sort of the well, OO design is about dividing the system into things that have an inside and things that have an outside, and deciding the things in the inside should be completely hidden, and then we create a new abstraction that from the outside, and you don't know how that thing is implemented. It might have lots of classes in it, or it might not. And then the sort of rule of thumb that is the sort of the secret sauce of OO design is what we call in the book composite simpler than the sum of its parts. So you want the API of this composite object you've created to be no more complicated than the APIs of any of the objects you're using to implement it, and those APIs of those objects should be no more complicated than the APIs of the objects that they're using inside them, and so on. So you have this sort of nested onion kind of model where there's no it's sort of scale-free complexity. That's difficult to do. Design is difficult, but when it clicks into place, you end up with this software structure that is really easy to work with in my experience, where the object just plug together. The other sort of trick really is having common interfaces, common protocols between objects that are not. So I often see people mocking concrete classes or having a plethora of different interfaces. I've got a product import and a product interface, or an iProduct and a product class, whatever. And it's just absolutely everything that a product can do is on that interface. But there's no attempt to create interfaces that are common between lots of different concepts in the system, so you can start treating them in the same way and plugging them together into interesting ways. And once you start refactoring the interfaces more rigorously so that you find a commonality and bring them up to be the same thing, then you can start like plugging your objects together and working to define new behavior just by plugging objects together rather than writing algorithmic code that lives in a class. You're like composing your behavior, and that's when it really, OO really kicks in. I don't know if that really answers your question. I kind of like wandered off into a different topic there, but yeah, I think.
You mentioned composites, and it's more about the composite than the class itself, and we tend to think that the unit, it has to be a class or a method, but it's about the behavior and the composite. Sometimes I wonder, some tools and some IDEs, they almost like guide us through creating one test for each class. Some plugins for Eclipse, for example, it forces us, or it at least guides us, suggesting that we should have one test for each class, and that if you have a class called product, then you have a product test, and then even creates tests for each method as well. If you have a method called, I don't know, buy, then you would have a test called buy test. So I wonder if that sometimes helps people make those. I wouldn't call mistakes, but to some extent, like not thinking about the behavior, but thinking about those units, those classes, and those methods. Yeah. When you say composite, yeah, what do you mean? What would be a composite in a system? That if not necessarily a class or a method, what would that be?
No, I mean, it is nice if every abstraction is represented in your programming language. In Java, that means making it a class. But the class, can be composed out of other objects. Often in Java, which is the language I use most of all, although I'm doing a lot more JavaScript these days, is you write functions, factory functions, or static methods in Java terminology, that will compose objects and then return them to you. So you don't need a class. So you just like building an object graph and returning it. So you can parameterize the function rather than having a class with a constructor. But it's roughly the same thing conceptually. I often have tests which are more less focused on individual classes when I'm looking at sort of interactions between different things, sort of robustness testing or testing some networking or some persistence. Something that's involving some third-party frameworks or services or libraries. Then I'm actually much more interested in how do lots of these things fit together. When it's my own code, I'm trying to think of what is the right abstraction, and that often in an OO language ends up being represented as a class. And so I'm trying to get to the point in my code. I like to get to the point where I'm focusing on the protocols, not particularly the classes. My tests are saying, right, this class properly conforms to that protocol and that protocol and that protocol, and I know how that protocol works, so therefore I know that I can compose them and they'll plug together properly, and then I can build a high-level concept that talks that protocol and that protocol, and it's made up of all these things, and I know that they compose well. And
Cool. Yeah, that makes sense. So we spoke about the fact that sometimes we write different types of applications, right? Sometimes there is a web app, sometimes there is a slightly different application, and we're moving. There's a lot of discussions around this new way of architecting and designing the system, which is microservices. Do you think there's anything different that we have to look at if we're working on a microservices architecture related to TDD and BDD or testing in general and system design? Would you look at the system differently, and if so, what would be different?
I think the key thing is you've now got a lot more places where errors can come in. Right? You're distributing your system across different services with different scalability rules, and different bottlenecks now will appear in your system. It's not like everything's in memory, so for a start, a lot of these requests can fail. And so I think and then especially when you start taking the services and other teams become responsible for the service, and also they're evolving, and multiple versions of them then have to be running at the same time. Now, microservices does complicate a lot. I mean, if you need it, having the ability to spin up services really fast and write them very quickly and manage a huge number of them and have them auto-scaling is great. I mean, there's no alternative if you're like working on a big website, for example. But you have to deal with the complexity and put tests around that. So I've been doing a lot of contract testing, so client-driven contracts, and sort of contract integration testing, so that different clients of a service can specify what they want. So that's kind of different from the normal TDD, BDD thing where you're like, right, you're responsible for the test of your service or your system and what it does and demonstrating that. With a more service-oriented architecture, being able to write tests for somebody else's service to specify this is what I expect the service to do, and then your tests become part of their build and deployment process is quite a change. But it's been really useful in my experience. You get away from that whole like, oh, let's have a big bang integration, release train idea, to just continually evolving services with client-driven contracts telling you like when services and clients are starting to become inconsistent, or then during the development process, it's a much lighter weight thing to deal with. You just have a chat with the other team, work out what the solution is, get your builds green again before anyone goes anywhere near production or even UAT environments or anything like that. And so it's much more agile in a way. Everything is much more relaxed and easy to deal with because every small change gets detected. So that's a really useful technique, and we certainly can bring that into a test-driven approach. Right? It's like you write your client-driven testing first, your client-driven contracts as part of your sort of testing process. The other thing we're doing, and people from Unruly, another company in London that does a lot of XP, they've been writing about monitoring-driven development. So they're talking about, right, well, the first thing we do is write monitoring for our production applications and to detect the change in behavior that we expect to see when we finally deploy it, and then we build the system and deploy it. Again, we've been applying that, and that's really useful, especially at big scale, because often in large websites, a lot of your system is distributed around the world in sort of CDN rules, and you have all these multiple versions running and routing, and something terrible, you're going to have traffic interfered with by various people around the internet and stuff, and so you don't really know what's going to happen until you put it in production. So you have to put it in production, gradually sort of bring in a new version and understand its behavior, and so monitoring-driven development is a nice discipline that helps you, start coping with that world.
Cool. So lots of new things that you've been touching, like contract tests and monitoring-driven development. And on the contract test side, have you used any particular tools, or if not to focus too much on the tools to not make the same mistakes that we made on the BDD side? What are some of the learnings from contract testing? Because I know teams who are just starting to do it and they're going through the first learnings. So if you've already done it, what are some of the things that you've learned that you would like to share?
So I think the way I've done it is to basically have each team write the test the way they want, and publish the results of those tests. So a service team has to have a live or live environment that clients can access, and a pre-live environment, and then clients can run tests, their own client tests against those environments, and then report them up to some dashboard or to the team that is providing the service and deploying the service. But we've built on some common tools. We've used like JSON schema, for example. It's been very useful. It's very expressive for describing the payloads and building predicates over those payloads. And we just use JUnit, a bit of Python for people who like writing Python, and py.test. It's a very lightweight test framework to use. So it's really about the process. Again, it's about having the shared artifacts and automated feedback loops to encourage the right conversations as early as possible to avoid the problems. Right? A bit like BDD is in terms of requirements between non-technical sort of stakeholders in the system and the software development teams. This is between different software development teams and it's much more technical in focus, but it's the same real idea. Like, get the feedback loops fast and facilitate conversation rather than having gating, release gating, and bureaucratic processes and big bang integration. The other, sorry, carry on.
Yeah, go on. Did you have something else? The other?
I think the other aspect of microservices that is less of an issue in sort of normal monolithic systems is the scope for error that can creep in between the components of the system. So you have a lot of third-party, you've got millions and millions of lines of code between your bit of JavaScript client code and your service running on a JVM somewhere. You've got routers and load balancers and IP switches and this and that, and it's all of a sudden it's much more complicated. What can go wrong? Bottlenecks and pinch points that you don't expect, feedback loops causing all sorts of spikes and everything. So if something can go wrong and if bad data can possibly get into your system, it will, right? So you have to focus a lot more on testing the bad stuff, and it's quite well. It's been found through empirical research that people doing TDD are not very good at doing negative testing that systems cope well with invalid inputs. Certainly, there was a paper presented at XP 2013 where the researchers studied software developed by teams doing TDD and found that of the defects that they found, 70% of them were found by negative testing. And I went back and I was working on an embedded system at the time, so I tried to chuck bad data into my system. I was writing some networking code. I thought I'd been really careful about checking for errors, but I just fuzzed some data into the system, and oops, oh my god, my code had lots of lots of terrible bugs in it. Through runtime exceptions, through lots of stateful code. It's an embedded system, so we had very little memory, so a lot of mutable state, and that's a really bad thing to have unexpected exceptions running through. So I started applying negative testing a lot more in my sort of TDD feedback loop. So again, the normal sort of TDD process is quite useful because you can, for a start, it'll have helped you isolate parts of the system that are doing parsing and doing sort of communication and transport level communication. So because you'll have tested each of these things independently, and that then gives you things that you can fuzz more easily. So you can, and also you'll have a lot of good input because you'll have been test driving the behavior of your system. So you'll have all the good messages that you can that you've used for your positive tests, and you can then just mutate them in various random ways and see how your system copes as a result. So adding negative testing into sort of networking stuff in the microservices world has actually been pretty easy. I've used a tool called WireMock, which has been really good and can do really quite low-level fuzzing as well. It can send totally incorrect HTTP responses back into your system to see how your HTTP layer copes with it and things like that. And that's been good for hardening our system and making sure that it's easier to monitor. We don't get unexpected exceptions running into the logs, that we're categorizing things carefully, which is all part of that whole outer monitoring driven development loop of continually improving how your system exposes itself to monitoring so you can understand its behavior.
Oh yeah, since you mentioned a few tools, I've come across this tool as well called Pact. I don't know if you've ever heard of it. It's to test RESTful web services in a more, like, you describe what kinds of responses you would expect for this particular get and for this particular post, and it's so contract testing called Pact. It's really cool. Mm-hmm. That's nice, and so that's very good ideas on the microservices side of things. What about APIs? What about if I'm building an API that, because the contract testing side of it, you try to write a test as if you were a consumer. What about if I'm writing an API for like hundreds of consumers, like a Uber, for example, just released a few APIs recently, and they had like all sorts of clients and travel websites like TripCase and Triplify, like integrating with those APIs. If we don't know, if a company is releasing an API, then they not necessarily know at that moment what the clients will want. And what do you do? Like, do you have any opinions on that?
Well, I think if you're really serious about being a platform, then you need people whose job it is to find out what developers want, find out how well the APIs are working for them in terms of the usability, sort of the developer experience, and treat developers like you would treat your users. Monitor the APIs, find common errors, but also just reach out and talk to them. I think it's difficult. I mean, being a platform provider is difficult, right? And a lot of successful companies just don't do it because the costs are huge. The actual effort of maintaining a good platform is very, very high. So it's easier not to. Yeah, I think the main thing is to actually try and write applications against it yourself as if you weren't inside the company, and see what it's like to actually try and use that API from outside and understand. But yeah.
Cool. That's a very good way of putting it. Like, I had never seen anyone put it that simply. It's like your developers are your customers when you're building something like that. Because if the product is an API, then trying to find out what the developers want. Yeah, you're right. Because companies do a lot of user research and to find out what customers want. If we're building an API, then why not try to find out what the developers who will be integrating with this API want? That's cool. Great. Okay, so moving away a little bit from APIs and microservices, if we think a little bit about the evolution of roles and people in this space of automated testing, not just necessarily TDD or BDD, but automated testing, we've moved from a world where developers wouldn't write a test. Developers would just write code. I don't know how long ago that was, maybe 20 years ago. To a place where it's a reality right now that developers do take a part in writing tests. So testing a system has been like the testers or the QAs that would sit in another building in another country. Sometimes I've seen that happen, to a point where we have developers taking more responsibility and being more accountable as well for the testing of the system. And that would you say that's the current reality? And if so, do you have any opinions about that? Or are we still not there yet?
I think that it's still not the current reality everywhere. I have seen companies where there are test automation teams in another building and in other countries automating the testing of applications. I've never seen that work well, so I think that you have to have testing as part of the design process. Otherwise, test automation just becomes too expensive, too error prone. The tests are too unreliable. So there's I think the most important message in the book is the feedback loop, that when a test is hard to write, go back and refactor it, improve the design until the test is easy to write. Not just hack it and change it until it's easy to write. Improve the design until the system is easy to write, the test is easy to write, and then write the test and continue around that TDD loop. And if you have automation teams away from the developers, you've lost this really important feedback loop. So the design limitations that are making the system hard to test are not being fed back to developers, and therefore the system is not becoming easy to test. So the job of the test automation teams is just continuing to be difficult, and the tests are a massive overhead. And what I've found is that at the system level, the changes you have to make a system test reliable and easy to write expose really useful information about a system. You have to be able to understand what it's doing, whether it's gone wrong, be able to diagnose why it's gone wrong, get it back to a good state, and know when it's got back to a good state. And that's exactly what you need to do in order to monitor a system that's in production. So the feedback, the sort of test-driven feedback loop of refactoring when something's hard to test at the system level makes the system much easier to monitor in production. In a sort of similar sort of feedback loop to at the unit level, it improves the internal quality and makes the system more easy to modify. Yeah.
Cool. Okay, yeah, I have to agree as well. Like, it's not a reality either at the moment, but it should be. And then if for the places where that is a reality, and that in the evolution, let's say, of TDD practices and processes and tools and ways of working and collaboration, what do you think is next? Like, if you could look a few years in the future, what will you see as being the next things that will come up and that are already coming up? You've already mentioned a couple, like contract testing, but do you have anything else in mind?
Well, I've been happy to see the sort of rise in popularity of property-based testing. I think that's really useful. So property-based testing is where your tests are structured as a predicate that defines a property of some aspect of your system, and then the test framework generates random inputs that are then expected to, that the system with those inputs are expected to have the property that your test is asserting, and that is great for finding sort of unknown unknowns. The fuzz testing I was talking about earlier is a sort of form of that, right? You're saying that given any input, I expect the system to behave in a sensible way, and then the positive cases you can narrow down and say, for all orders that are sent to America, I expect you to have to pay duties, and you can sort of see that going from, oh look, here's an example, which is great as an illustrative aid and as a form of documentation, to right, here's a property of the system, is a big step forward. And so I've been, now I found myself where I'd gone from becoming test infected back in the early days of XP and feeling really uncomfortable when I was writing code without writing tests for it. I now think I'm becoming property test infected, where if I'm just writing example-based tests, it doesn't feel right. I need to actually test everything, and so I'm writing a lot more tests like that, and that changes the way I approach the problem in a TDD way. I'm still not quite sure of how examples and properties sort of fit together, but I find it a really useful tool, especially for more functional code. It works very well, but it works well for OO code as well. And I'm starting to think that test automation is not about checking examples. I mean, test automation is a sort of search optimization problem. So rather than saying, let's run through a test pack and just run through everything and tick the green box for every single test scenario that we've got, think of it as saying, well, there are bugs in a system. There's always bugs in a system. How do we write a testing tool that will automatically go out and search for those bugs rather than just run through predefined scenarios? So that's what I'm thinking about in terms of testing, and how you then sort of apply that kind of thing in a test-driven approach. I don't know. I'm still working it out.
Sounds like a bit of intelligence to the testing framework itself, not just doing exactly what someone says, but bringing some exploratory intelligence to the. Is that what it is?
Yeah, I've been experimenting. Oh, we're getting some feedback. Experimenting with meta heuristics, some sort of genetic algorithm approach, and and also model-driven testing is a bit like that, I guess, in terms of sort of generating random models based on some understanding of your domain. Yeah, it's fun to play with, but it's still early days yet.
Sounds good. We've got some questions coming over. We've got 10 more minutes, and then what if we just try to answer some of the questions that we have? I'll try to mention one, which is from Marcos. So Marcos is saying didn't really get the point of languages and frameworks impacting TDD. Isn't it the same as saying BDD sucks because of Cucumber?
I'm not sure what he's referring to there. I mean, tools will affect what code you write. Back in the old days of Java, when we didn't have really powerful refactoring tools, people would want to put getters and setters around every single access to a variable in case they wanted to change it. Nowadays, you just can encapsulate a variable across millions of lines of code in under a second, and it's not really a big deal, unless you're publishing an API out for public use, in which case it's a different matter. So I do think that tools change the design you do, but the fundamental feedback loops, I think, the way you go about thinking, TDD is really a sort of thinking process, a thinking tool rather than a testing tool, right? Or are universal between languages. I think some of the problems I've had with Cucumber are its inherent limitations, which are also its kind of point. So every tool has a place, and a place where it's not applicable. Just like mock objects, right? They were designed for a particular context, and there are contexts where they're worse than not using them.
Cool. There's one more question from the Twitter feed, and then I'll ask Britt, who's got access to our Q&A from the Hangout, to throw maybe a few more. So there's one question on the Twitter feed from Philip Schwartz, and he talks about something you said around law of Demeter, which you said something like OO code that follows LOD is easier to understand and maintain. And apparently other people said other things that he quoted. I think Martin Fowler said stepping stone towards co-locating behavior and data, not worth highlighting. I don't know if you have access to this particular tweet, but do you have any, since you said something like that, do you have any comment on it?
Did I say that? I don't know. Yeah, I guess it's what you're used to as well, right? Before I started doing industrial programming, I did a PhD in, which involved using process calculi to model concurrent systems. So there you model your system as state machines that communicate via messages that you can compose. And when you compose them, those compositions collapse down into simpler state machines, because some of the transitions of those state machines are hidden when you compose them, and it's all it's got a nice formal mathematical model, and you can prove properties of your system and stuff. Anyway, that was a very attractive way of thinking about writing, designing systems. You couldn't write in the process calculus, but you could think about your design in terms of that. So when I came to Java and OO and Ruby back in the day, and I wanted to write my objects like that, even though it wasn't a perfect fit, just like Scala isn't a perfect fit to the lambda calculus. I wanted to think of my objects a bit like the pi calculus. So in that case, sending messages to each other and tell don't ask, it sort of fitted the way I thought, and so sort of the work we did back then on mock objects was also sort of fitting into that way of thinking about design. I do think there is something fundamental in the law of Demeter about how you shield one part of an object-oriented system from the rest of the system. It's all about hiding knowledge and information hiding, so that an object has an inside and an outside, and it doesn't know what's on the outside apart from the types that it has direct reference to and the types that get returned to it from sort of messages that it calls, right, messages it receives, and that you don't sort of go through a chain of types into types defined in another part of your system. I mean, the law of Demeter is actually defined in terms of types, while sort of Tell Don't Ask is more about actually talking directly to objects, to instances. So yeah, the law of Demeter is about, like, don't suddenly find yourself coupled through a chain of object graph references into other types of other parts of your system, and then you've got your different domains of your system all coupled together, and a change in one part of your system will ripple through and suddenly affect an unexpected part of your system. So I think that's something to aim for. Different programming paradigms aim for it in different ways. The OO way is the law of Demeter, or at least that's how they described it, and then the functional way is different.
Cool. So we've got some other questions on the Google Hangouts, so I'll throw it over to Britt. So Britt is one of our behind-the-scenes superstars who are helping organize this, so thanks a lot, Britt. And feel free to jump in and ask a few more of the questions from the Google Hangout.
Sure. Here's a good one. This is from Raphael. When reviewing code, some people try to find traces of the code that was written using TDD. Do you think this is really something that can be treated as a metric to evaluate if the code and the developer are good?
No. I mean, I wouldn't want to apply metrics to decide whether a developer is good, where the metric's just taken from some measurements in the code. I mean, quality metrics of code are notoriously difficult to actually calculate anything useful from them. And can you really tell whether it was written TDD? Keith Braithwaite has done some experiments where he has found some different trends in power law distributions of method sizes or method complexity. It's different between TDD code and not TDD code, but he has no idea what the significance of those different equational parameters are. And so, does it tell you whether the code is good or not? I mean, at the end of the day, code is really judged by how well it is working. Right? The agile principle of working code over comprehensive documentation is code working. So code is actually doing its job, so you can see how well it's doing its job. Really clean code that's not doing a job. It's just
okay.
Thing, right?
Got it. Here's another question. Is there any situation in which you want to think on your class design and you don't do TDD?
Yeah, I mean, I do. It depends. Sometimes I have an idea I want to implement, and I like to do a bit of design. It's my guilty secret. Sometimes when working on a big legacy system, you can just refactor a bit and follow some very like the 4 simple rules of design and just clean up the code and discover through duplication new concepts. But sometimes you find that the code has been written into a corner because of technological choices, frameworks and whatnot, and you've got to sit down and think, what is the thing we're aiming at? What is the design that we want to aim at that will solve the problems that we've painted ourselves into a corner with? So in which case, yeah, I do. And also sometimes I don't do design at all. I just when the system is small, I just mash it all into one big thing, and then only when it gets bigger do I refactor it into a structure, when I have a better idea about what a system should be doing, and the need for structure arises. In smaller systems, structure maybe is just getting in the way because you don't yet know what the right structure should be for the shape of the system as it's evolving.
Okay, great. I have one more question, and then I'm going to pass the floor back over to Fabio. He asks, What do you think about applying TDD? Is defining aggregates and predefined categories of objects to implement features against emergent design?
He's defining. Yeah, I mean, yeah, I don't. I like a lot of what's in DDD, but also some of it doesn't really match the way I think about things. You know, I'd much, yeah. So DDD is very data centric, at least sort of what I see of it, and a lot of how it's described in the book. Where the way I want to create an OO design, I'm much more focused on the protocols between objects. That's what I'm focusing on in the design. How do things communicate? Doesn't really matter what they are. So can I find these like sort of fundamental patterns of communication in the system, so that then I can start just plugging in like small pieces of behavior that will then have sort of systemic effects across the entire graph of objects. That kind of sort of view of OO design doesn't always fit with the sort of DDD way of designing. It doesn't mean it's wrong. It's just you end up with different designs, and the sort of approach that I prefer, and it's sort of written about a bit about in the book, is slightly orthogonal.
Cool. So thanks, Britt. We're 1 minute over what we said, which was going to be in 1 hour. So I really want to thank you, Nat, for everything you've said. I think that was a very informative 1 hour conversation. I myself have learned a lot from that, and I'm sure everyone who was watching learned a lot. There will be a post on this, and there will be an offline version of a recorded version of this that we'll post. So if anyone has anything else, feel free to ping Nat on Twitter. I'm sure he can answer questions as well. His Twitter is at Nat Pryce, or feel free to follow him, or even follow me as well, Fabio Pereira, or ThoughtWorks as well. We'll actually post this offline, as I said, and there will be lots of other conversations going on. Keep the hashtag TDDs evolving going if you want to comment anything about it. Do you have any final comments, Nat?
Well, thanks for hosting it.
Cool. Thank you very much, everyone. Thanks, Nat. Thanks, Britt. See ya.
Thank you.
Thank you.